Suppose an object has three forces acting on it. One like this, and one like this. I'll call that F1, F2. And the third force is such that this object is not accelerating. What direction and magnitude should that force be? Okay. How are we going to do that? Well, these two have components that point that way, this way, and that way. And these seem to be very close to the same size, but opposite direction cancel. And so these ones alone are pointing that direction, about twice the size of one. So that would be the force, sum of these forces. So I'll put F1, comma 2 net. Alright. So that's the net force from just these two. If this isn't accelerating, well, Newton's second law says that there can't be a net force, which means the third force must be pointing the other direction and of the same size as this one. So this must be F3, so that when you add this one with this one, they cancel out. So this would cancel out with this one. So our net forces sum together as a vector. So these y components of F1 and F2 added together, and separately the x components of F1, F2, and F3 added together. And in this case, by defining it to be zero acceleration, meant the net force must be zero as well. Well, what if it was accelerating? Let's say this object was accelerating to the right. Well, I would have to redraw those forces, and this one, should it be longer or shorter than it was up here? If it's accelerating to the right, that means that this force was bigger than this force, so we have a net force overall. So we want a net force overall in this direction, for this case down here, which means this one must be shorter by some amount. How much? I don't know. The shorter it is, the more it'll accelerate. But this would be the case if this is now accelerating. So this was A equals 0, and this is accelerating that way. So this vector is now smaller than the sum of these horizontal components.